ready? Okay, before I go through past year's paper, I will summarize all the key points for the 3 topics which will be covered in the term test. Okay, topic 1. You try to follow me, please. Okay, topic 1. The first important concept is standard enthalpy for reaction, which is defined here. Alright? And the standard enthalpy or heat of reaction is defined as the energy transferred from the surrounding to the reacting system under this condition. Alright? And then how to calculate? Please, this formula, equation 1.1, you have to know. This one will not be given to you. It means you need to calculate the heat of reaction by all heat of enthalpy of formation for all products minus all reactants. Please remember, inside here, you need to include the proper coefficient. So it means the equation, the reaction must be well balanced. Okay? One more point. Please take note. Okay. Please take note. The enthalpy of formation for single element molecule like hydrogen, oxygen, nitrogen, or some metals like copper, all these kind of molecule, what is the enthalpy of formation? 0, 0. By default, it's 0. Will not be given to you. Some 0 values, you may not see it. Okay? And then another thing will be the enthalpy of formation is dependent on the status of the substance, whether it's liquid, gas. For example, if you have water, so that you know, if finally you have some examples like this, right? So you have water here is in liquid form, you cannot use the wrong value. If you use the water for gas, it will be the wrong value already. So this is another point you must be very careful for this part. Okay? So when you calculate the heat of reaction, please try to use the proper enthalpy of formation. Definitely we will give you the necessary values for some substance, for example here. But here for oxygen, we may not be given to you, right? So the oxygen will be 0, right? Okay? So this is the first important concept. Second one will be what is exothermic reaction, what is endothermic reaction. So please try to memorize the highlighted definition here. Alright? So for exothermic reaction means the energy released during the bond formation in the products is higher than the energy absorbed during the bond breaking. So the diagram, you need to know, roughly it's like this. Please, when you plot the energy diagram, you need to plot a few things. Don't forget to label. The y-axis will be energy. At least 3 points you should show here. Energy level, this is referring energy, normally is in this units. Then what are the reactants? What are the products? Then this is the enthalpy of reaction. If you know the reaction, the reactants you write here should be the balanced one. And then the products here should be the balanced one as well. Okay? So this is for the exothermic and endothermic. Don't confuse these two. Exothermic means what? Means the energy from the reaction will be released to the surrounding. So the products will be lower, right? Okay? But if let's say you summarize in this table, you compare exothermic and endothermic. The first one, no problem. One is a negative. Exothermic, enthalpy will be negative. Endothermic will be positive, right? Directions of energy flow. Okay, I want you all to answer this. Temperature of surrounding for this two. Which one will increase? Which one will decrease?
Exothermic increase.
Exothermic. You did it in your practical one, right? You remember you have this reaction will release heat. Then your solution inside the beaker is actually the surrounding already. The surrounding will receive heat, so you observe a temperature rise. Okay? So for exothermic reaction, you observe a temperature rise. Correct? So this is for the first important part for topic 1. Second part, there are a few types of chemical reactions. There are 4 types here. Try to describe the definition and also give one example for each. You have 4 types. First one, second one, third one, fourth one. Okay? Just try to memorize what is the basic definition and the example. Give one example. And the difference between these two, homogeneous and heterogeneous reaction, what's the difference? Homogeneous referring all the reacting species will be in the same phase. But for heterogeneous, normally will involve more than one phase. For example, if you have a catalyst is in the solid form, it's in the solid phase. Okay? Then the last part for topic 1 is the calculations of reaction rate. What is the definition of reaction rate? Originally, this is the definition for rate of disappearance. We write minus dNA over dt, right? Then you have an example on how to calculate the rate. How to calculate the rate. Okay? This part is for your knowledge. Okay? We will not test you this part. Because this part is different types of definition. We actually will focus on the first type only, this one.
Yeah, volume.
Per unit volume. This is what we are commonly using now. We are using now for the liquid phase reaction. So the other types we will cover in other topics. So we will not test you this. All this part. Okay? So these are the key points for topic 1. Any questions? So the last part will be, you need to know how to read from this table, right? Never mind, the enthalpy of formation definitely will be given to you. Any questions? Can So this is for topic 1. You are happy now, right? You want hints, right? I give you hints already.
Lol.
Topic 2.
Of course.
Can we move on? Yes. Okay, topic 2 is the first important concept is the order of reaction. Remember, we already mentioned the order of reaction can be any number. Can be 0, can be 2.2, just like the tutorial, 2.3, like that. 0.4 can be any values. Okay? Alright, so the definition, here what we need you all to know is this. Okay. Reaction rate? Order of reaction, no. Normally, no. Yeah. Okay, first concept. What is elementary and non-elementary reaction? Highlight. You need to know the definition. Okay? So what is the definition of elementary? Because if you don't know this, some questions the order might not be given straightforward. We will just tell you the following elementary reaction. How? If in that case, you must be able to tell by yourself. Okay, for example here, right? If we say it's elementary, so it means the order here, M and N, will equal to the A and B here. Alright, so the respective order of that particular reactant should equal to the final coefficient inside the balanced equation here. So this is the first important concept. Then if not identical means it's non-elementary. Okay? So this is the first important concept. Second one, equilibrium constant. Yes, equilibrium constant will be tested. Alright? Okay, so for equilibrium constant, it refers to a reversible reaction. So means this reaction is reversible, means there will be a forward reaction and reverse reaction, right? So, for example, this reaction. So forward reaction is here, reverse reaction is here. Then later on, when we talk about the rate, right, we are referring to the same substance. So you see here, you have two reactants, right? You have nitrogen and hydrogen, right? Okay. So what we are referring later on, you see it's highlighted. We are referring to nitrogen. So it means you are referring to the same thing. You cannot say you compare nitrogen forward rate with the hydrogen reverse rate. Cannot. You are referring to the same molecule. What is the forward rate and reverse rate? Okay? So when we write the rate equation, please write properly like this. So at least you should write these few equations. You need to show your working. What is the forward reaction rate? Okay, for nitrogen. So will be K. Please take note. Some of you may confuse a little bit here because you are writing for minus R nitrogen. Some of you just write K nitrogen only. Is it correct? Please, because the reaction rate will be affected by all reactants. So wherever you write the rate equation, you must include all reactants, no matter which rate you are referring to. This one, the nitrogen is relevant to K1, so this K will be different for different reactants. But the concentration of all reactants will affect the reaction, so you must include both here. Please, I tell you later on, there will be some of you will give me the answer like that. You write nitrogen, you will write K nitrogen only. No, you must include both. And then for the reverse, please take note. Please take note. The reverse reaction, this is the reactant. Please, when we write the rate equation, right, minus RA equals to KC something, we are always writing for reactants. So for the reverse, now the reactant is this, ammonia molecule, right? So you have to write the ammonia here. Are you all following me? Okay? Always remember, you write the reaction, you always follow all the reactants. Although now the rate here refers to nitrogen is the product. Okay? When you write R something, now the nitrogen is product, but the rate is still affected by reactant. Then at equilibrium state, please, you need to write one balance here, means the net rate will be 0. If net rate is 0, means forward rate should equal to reverse rate. And then the next step, let this equal to each other. Finally, you will have this. And don't write wrongly. Your definition of equilibrium constant for the reaction refers to forward over reverse. Can you write down, highlight? Otherwise, your answer will be reverse. Okay? We are referring to this is your forward reaction. K1. Our reverse reaction is K2. So final equilibrium is forward over reverse. Okay? So by the concentration will be products over reactants. And one more thing, any units for equilibrium constant? Any units?
Depend. Equilibrium constant.
Any
Depends.
units? You look at here, any units?
Got.
Any units?
Got.
This on top is concentration square.
Oh, bawah
Bottom you have concentration cube. Finally, do you have a unit?
Yes.
Yes. Don't answer so fast. Say no. Depends on. Depends. For this case, definitely yes, there will be a unit. Okay? So your final complete answer for the equilibrium constant should be your value plus a proper unit. Unless it happens here is a square, bottom also square, it cancels off, then it's dimensionless. But for this case, it's no, right? Definitely got units. Okay, Ken. So this is for equilibrium constant. Are you all clear? So one more thing here, the final concentration for all products and reactants refers to the concentration at that equilibrium point. Okay, means at the final point, equilibrium state. Okay? So this is for you see here the units, right? Next, units of Reed constant. Units of Reed constant you learn a lot already. I'm sure you are able to do it. No matter first order, second order, any other orders, right? Okay. You should be able to find for all types. Anyway, if you forget, right? Can you all come back here? You see, this is the basic definition of rate, of reaction rate, right? So from here, very easily you can tell what is the rate units. Number of moles over liter and time maybe minutes, right? So it's more per liter per minute. It's very common. So means this side you will know the units. Then this side depends on the order, right? Then you can very quickly find the units of K already. There are some exercise behind here, right? Have you tried? You try to do it, Can? So this is the second part for topic 2. Okay? The last part. Last part is Arrhenius equation here. Refers to how the rate constant is affected by temperature. Okay, for this part, take note, there are two cases. Remember in the tutorial we already covered. If let's say you have only two temperature values given, right? How do you do it? You just write K1 equals to what? K2 equals to what, right? Then you compare the two sides. Remember, this is the first case. If you have two temperature values, follow this way. Very easy. You compare A, then will be cancelled. Then you can find E over T, E over R very easily. Then the other way will be you take ln directly here, like this. But usually this one is more convenient for you all to plot graph. If you have more than 2 points, more than 2 points means you have a table, just like, okay, wait, for your practical 3, right? Your e-practical, I have already extended the submission date, will be after your term break. You have enough time. Okay? But don't forget, you need to submit. Alright? And the one is referring this. You have 4 temperature values, right? 30, 35, 40, 45. At each temperature, you have 1 K, right? In that case, please, you need to apply this method. And you need to plot. Okay? After you plot, you will have 4 points. Then you will draw a best fit straight line. Best fit straight line. Then you display the equation. From there, you can find what is the gradient and what will be the intercept. So you can find E, you can find A. Are you okay with this? How is your finding? When temperature increase, the K should increase or decrease? Some classes already done. Some of you already done it. When the temperature increase, K should increase. Otherwise, why do you consume more energy to increase the temperature, right? The K should be faster, right? Okay? Hannah? Alright, so this is topic 2. Any questions? Any questions? Good enough? Hannah? So some of you say, will this graphical method tested? Yes. This kind of graph? Yes. We will not give you many points. Don't be so scared about graphical method. We will give you a proper graph. We will give you maybe 4 points only. Okay? So you can plot easily. Okay? But you need to know how to calculate. Listen, because nowadays you rely too much on the computer. You rely on the Excel. You don't know how to find the gradient already. So how to find the gradient by yourself? Huh? How? Because today some of you are still asking how I find okay. Normally you need to plot like this, right? You will have 4 points, right? Then you just draw a best fit straight line. Best fit straight line means, best fit straight line means your points might not be on the line, but it's along the 2 sides of the line. Okay? Then after that, how to find the gradient? The gradient, you need to choose any 2 points on the straight line. Don't choose the given points. Now you have 4 points. These are your experimental data, right? Now you need to choose any 2 points on the straight line. Try to cover the full range. You cannot say I choose 2 points here only. So try to cover, for example, I choose 1 point here, another one here. Okay? After you choose these 2 points, draw a triangle. Alright? After you draw the triangle, try to find what is this delta y. Okay, what is this delta x, right? So your gradient will be delta y over delta x. Delta y equals to your minus E over R. Why minus? Because your line is this way, decrease, unless your line is this way. But for this part, please remember, your line is always this way. Okay? So from here, you are able to find the gradient. From here, you can calculate the E. Can? Okay? Hey, please take note, if you write by delta y over delta x, should this value be negative or not? Yes or not? Yes, negative. Okay, otherwise, please, your E is always positive. E cannot be negative. E always positive. E refers to the energy, right? Okay? Okay, now you are clear? And then, what about the intercept? Listen. So for this case, right, it might be very difficult to extend to here to find your ln A. So how to find the A? How to find the A? You have one way, either to find from this point where the ln k equals to 0, or you substitute this value back into this equation directly. Okay? Now you have the k already, you have t, you have e already. Then you can find the a here from this equation directly. You cannot find from the extension because sometimes you may not have a starting from point from here. You may start from somewhere because your 1 over t is a very small value. Okay, you may not start from 0 here. You may start from somewhere. It's fine. In that case, don't extend to find your A. Use this equation to find your A. Are you all clear? Okay now? So this is for topic 2. Okay? Let's move on. Topic 3 is regarding batch reactor. Okay, for batch reactor, you need to know what are the, you need to list down what are the main characteristics of a batch reactor. So what are the points? Here. So these are the points, at least 4 points. Okay? At least 4 points. So it's a closed system. Total mass of each batch is fixed. The volume and density may vary. Okay? Energy level, reaction time, operation is unsteady state. Try to give at least 4 points. Then after this, listen. For topic 3, if I don't look at the notes, alright, you should know there are 2 main methods. One is integral method, another one is differential method. Okay? So for integral method, how do you start? You need to know what is the meaning of constant density or constant volume system. I mentioned a lot already about this. If the reaction is in liquid phase, is constant volume system, in that case, this rate can directly write as minus dCA dt. So this is from here, from the definition, from here. So this is the very first equation you need to know. Okay? Second equation you have to know will be what is the order of the reaction, based on the order, right? So then you have a first order, how to derive, right? For first order, this is the final. Sorry, I'll make it too big now. So this is the first order, okay? Then you need to know how to plot. So for first order, what is the graph you need to plot? You need to plot this log CA naught over CA versus time. Will be the straight line will pass the origin. Okay? Then we also have second order. Any other orders, right? So here you have two methods for integration. One is directly just derive, just use the equations. The second way will be you need to plot. Remember, I mentioned many times already, we only require you the simplest case. Always start from assuming first order. First order means you have to plot this, right? You have to plot this first. Then if you have a curve, means your assumption wrong. Then you have to try second order. Okay? So this is the graphical method for this part. So this is for the integral method. We can quickly go to the... So anyway, this is for you all to assume, then plot, right? Differential method. Please, differential method, you need to know how to describe. How to describe. Describe means you need to know the step one usually is to plot CA versus T. From there to find the gradient. So it should be somewhere here, here. So written somewhere.
Belum. Kat topik 3.
Alright, so differential method, listen. The first graph will be CA versus T. Then from the first graph, you need to know how to find this gradient minus dCA dt, right? So that is to draw the tangent line. Okay? After that, after you get the 4 points of the gradient, then you need to plot the second one based on this. So we'll be ln this gradient versus ln CA. Then from this straight line, you will get a gradient. Inside here, the gradient will tell you what is the order and what is the rate constant. Please, you need to know how to compare the integral and differential method. Can you all tell me which method is more accurate? I asked you in all your tutorial classes already. Differential is more accurate? Wrong. Integral method. Okay. Differential method, the advantage will be you don't need to know the order. The order is unknown. And the K also unknown. You have two unknowns. So this order and rate constant can be found by this method. But integral method is impossible. So integral method, the order must be assumed or must be given. Okay? And one more thing, when you plot this gradient, right, it will give you higher error. Different people, you draw the line, will give you different answers. Correct? Okay. So this part, how will this be tested? Listen, we will not ask you to draw the tangent line because this part is too tedious. Everybody will give a different answer. Just like your tutorial 6, we will give you the CA. We will give you the CA, we will give you the gradient. Then from there, you calculate ln, then you plot. Okay? From the plotting, how to find the order? Just the same thing. Just like
then if the order is typical.
okay, we will give you this. So it means from the first graph, we find the gradient already. Then we'll give you the 4 points of CA and the gradient. Then what you need to do, you need to calculate log CA. You need to calculate log of this. Okay? After you calculate log. Okay, you use the 4 points. This time you finish. Okay, so from this, you draw the triangle again from the straight line. Choose any 2 points to find the gradient. Delta y over delta x will be the order of reaction. So means your reaction could be like this. So alpha is determined from the gradient here. If you plot, you calculate delta y, delta x will give you the order. And then how to find the k? K will be this from here, long k. The y-intercept will be the k. Will give you the k. Okay? So this part, this is the way we will test you, right? Okay? So this is the differential method. So that's it for topic 3. The last part, method of access, this one we will not test you. And because this one actually is just to simplify 2 reactants into 1, then the rest will be the same as integral method, right? So this part, even we test you, is actually still under integral method, right? You just need to know how to simplify the 2 reactants into 1, right? Okay? Any questions? If no more, can we go through past year's paper? This is the last year's paper.
You're not going through the rest of topic 3.
Not tested.
So these are the batch reactor or not tested?
Yeah. Ras. So the last one ataupun like go through like siong and not tested.
Yeah. And I don't understand what it was talking
Okay,
about.
listen. This question is a little bit tricky here. See here. It's never mentioned the following elementary reaction. Didn't say, right? But it's written, it's given as this. This reaction is first order for hydrogen, alright? And second order for nitric oxide. So, how to write? You see, so although here is 2, doesn't mean when you write re-equation will be Ra equals KCA squared, KCB squared. Wrong. Given, please follow this. This is what is given. Okay? So the answer should be
Is it last year's paper or the year paper?
I'm not sure.
I think the answer should be follow inside the thing, right?
Legit, I don't know, I'm not sure.
Okay, so the answer will be, this equation must be correct. You follow this. So you can tell this is non-elementary. Why non-elementary? Because for hydrogen there is a 2, right? But given is 1. Clear? So this is the point 1. And then how to find the units? I think this part is quite easy, very straightforward. Okay? To find the units of K. Then the last part. This one we never test you before, right? You see this type of question before. See, if the concentration of this reactant is doubled, but the concentration of the other one is tripled, what will be the reaction rate? How would the reaction rate change? Okay? So you just follow the rate equation. If this one double means 2, right? You write 2 here. So this one will be 2. This one will be 3. So finally, 2, don't forget outside you have a square, right? So this one will be 4. So will be, you have a factor. So the rate will become 12 times of your original. Okay? Okay, Question 2. Question 2 is regarding the equilibrium constant, right? Okay, see here you only have one reactant for forward reaction, but for reverse reaction you have 2. So how do you write forward and reverse? So at least you should be able to write here, for forward reaction is K1, then concentration for S squared. Then for the reverse, you have 2 reactants. The balanced coefficient is 1 and 3, right? So it's 1 and 3. Then at equilibrium state, these 2 should equal to each other. Let them equal. So this is the final. Don't forget, this is forward, this is reverse. Forward is always on top. Okay? Then I think the other one will be, some of you may be quite confused about how to find the correct equilibrium concentration. I mean, this part would be very confused. See here? 50 of S were fed into the reactor. So this is your initial. Then at equilibrium state, listen, 70% of S has been reacted. So how much of S will be left?
Why?
50 times 50%? 30%. Correct. 30%. Then from here, you should tell, if you use 2 moles of S, should generate 1 mole of B and 3 moles of C. I think this part is confusing. Some of you may not be able to find correctly. Okay? So you need to know to find out what is the correct B and C at equilibrium. Okay? Finally, there's another constant is given. The rate constant for the reverse reaction is given. So this is K2.
You were like 1 millimeter away.
You are going to find the equilibrium rate constant and forward rate.
What axis?
Oh no, that was like my post-it.
So the equilibrium you can find from here. Then from here, K1 is unknown, K2 is given, right? So you are able to find this from here. Okay.
Oh wow.
So this is your final. You can either find this first, and then you find K1, or you find K1 first to find this later. Also can.
Oh my god, seriously.
Okay? So this is for question A2. Are you okay? Any questions? Next, A3, very straightforward. For A3, you see the re-equation is given. This is a second order. Can I ask you, is this elementary? Yes. Yes. Although it's not mentioned, right? Okay. Yes. But it's given directly lah. So you need to derive and then calculate the time needed. So don't ask if the question never say, you still need to show your working. Okay? So it means you need to show this. Alright. So at least you need to show these few steps. Remember, this is always the one. We say you always need to write this first. This is for liquid phase. And then another one based on what is given. Then you let these two equal to each other. Okay, then from here you derive. Please, this formula CA equals to C naught times 1 minus XA. Everybody, you need to memorize. Will not be given. You have to know. Then after this, you calculated. This is your K. Then another
Can
thing
she like
is...
tell us what is given? Huh? What is given? Like she always keep on saying the ones that's not given, but she never say what's given.
That's her trick.
You find the K first, then you find the time needed for this conversion. Please also be careful with the units. What units is given here is mole per meter cube for concentration. Okay? Any questions?
No.
So can we move on? Okay, question B, 20 marks. Alright? So you see the first part, this is how you need to describe how is the differential method can be applied. Okay, the answer is here. Okay, so means these basic derivations you still need. Then after that you will see you need to describe from the collector data plot CA against T, right? Then you find the gradient and plot this ln versus this ln CA. Then from the y-intercept you find the K. The gradient will tell you the order of reaction. So this is the differential method. Okay? Alright, then the last one, B1B. The re-equation is given already here. The order is 0.4. See here. And also take note, the units given is mole per liter per hour. Then here the second part is to find the concentration and conversion after 2 minutes. So this is the point you must be careful with the units given. Alright? So the derivations will be similar. Then you have to repeat again. Alright?
My sister sent me. Then my dad was like, love to see this one also clean. Then I was like, sama tak. Then my dad was like, Daddy datang boleh tolong clean.
This is the final. Okay, you repeat again. You just derive until I think only this last part. This part. how to find the CA, then finally find the conversion. And one more thing here. 2 minutes, you have to convert to hour because the given rate is based on per hour. So this is the only point you need to be a bit careful here. Okay? So, what equations will be given behind? Usually will be the Arrhenius equation. That's the only one will be provided.
Huh?
Yeah.
Hey, Ras, they
Because
only
no
provide
other
one
equations
equation.
needed,
Huh?
right?
They only provide the
All these you
Arrhenius
need to show
equation.
working like that.
Of course lah, the rest of we remember. She told
Okay,
say
that's
already,
it.
but we need to
I know, but like,
I have already
Then we
uploaded
need to know the
another
derivative
year.
part. What is that
So
all?
means the year before
Yeah.
this year,
You see got try.
for you all to practice
lah.
by yourself.
You wanna compare Haji, right?
oh dear.
You wanna compare? Nah, come.
What?
He combed his hair. Yeah, it's up. This one Haji thing,
Oh.
right? Lah.
Try your best. I'm more worried. I don't worry about you who are here today. I'm more worried about those who are absent always.